Hello my friends, here's a chemical tutorial from me how the titration of magnesium and or calcium works. The chemical principle. When you titrate a metal ion like calcium or magnesium, you use a chemical compound that is called EDTA. EDTA is a molecule that has a big ability to absorb metal ions. We call this EDTA. EDTA is also what we call a titrant. That is the last fluid when you titrate calcium and magnesium when you do a manual test. This is EDTA. And it has an ability to absorb metal ions like calcium and magnesium. And then we have to have a color dye that tells you when you have absorbed all the metal ions. You must have a sort of indicator, and that is the reagent 2 in most manual test sets. And also you have a bottle 1 in most kits, and that is because you have to increase the pH, because this EDTA will not work if you don't have quite high pH. If you increase the pH, this EDTA will be possible to absorb calcium and magnesium ions. If you have a lower pH, this EDTA will not be possible to absorb calcium and magnesium. So therefore you must start with increase the pH to 8 or maybe 10, depending on if you want to titrate calcium or magnesium. Okay, so what is happening when you start? First of all, you have this color dye. The color dye is blue from start. The color dye is blue when it has new metal ions attached to it. The color dye in a fresh water solution with new metal ions is blue. Now you add metal ions like calcium magnesium, or this color dye is in contact with calcium magnesium. The calcium and magnesium will get stuck to the color dye, and then the color dye will change color to red or pink. So this is what's happening before you start the titration. You have calcium or magnesium in the water, and that calcium and magnesium will attach to the blue color dye, and then the color dye will turn red. So here is the start situation. You have a pink color in the water due to the magnesium and calcium that has been attached to the blue color dye that then turns to pink. Okay, now the goal is to remove the attached metal ions from this color dye, and there the EDTA comes. Now you drop EDTA in the water solution, and the EDTA will remove the metal ions from the color dye to itself, because EDTA has much higher absorbance of metal ions than the color dye, so the EDTA will win, so to speak. So now we take EDTA down in the solution, and EDTA will take away the metal ions from the color dye one by one in the molar concentration 1:1, one by one. And when the metal ions is disappearing from this color dye, it will go back to its original color, blue. So now all the metal ions have been removed from the color dye by this EDTA, and it has turned blue. Now the metal ions are stuck in the EDTA. EDTA is colorless. So the first solution is to raise the pH, because otherwise the EDTA will not work. It has not the affinity for the metal ions in a low pH. Second, you add this color dye and it absorbs calcium magnesium and turn to red due to that. Third, you add the EDTA, and EDTA will remove the metal ions from the color dye, and then the color dye will go back to blue. Now you know how much EDTA you have added, and that is the same amount as you had calcium and magnesium ions from the start.